Okay. So uh, relative motion is like the motion relative to other. So if we think about a object is moving, okay, so we calculate the velocity of this
Yeah.
object with respect to the ground.
Yeah.
That's the usual thing. Okay.
Yeah.
Now, or the static object. Now, if two objects is moving, say for example, one object is moving to the right, the other object is also moving to the right. That means they are
Yeah.
on the same line or
Yeah.
same direction they are moving. So what is the relative speed or relative motion or relative velocity of one? Actually, relative velocity, whenever we see, okay, different directions, then we use the vector notation basically. So what is the relative? Say, for example, this is A, this is object B.
B.
So what is the relative velocity of B with respect to A? And what we can say, what the vice versa, what is the relative velocity of A with respect to B?
D.
So whenever we have this kind of situation, we do the vector summation or vector subtraction method.
Yeah.
Okay.
Okay.
So I think you already uh, have that knowledge, like for 2D
Yeah.
or 3D uh,
Yeah.
case. Okay.
Yeah. Okay.
So even if I just show you a one example, like quickly. Uh, so basically, like one object like V, uh, say for example A, it's moving
Yeah.
to the east. Okay,
Yeah.
so this is one direction,
Yeah.
and another object is moving to the how to say uh, VP moving to the north. Okay,
Yeah.
because we can say okay, this is moving to the north.
No, it's
So what is their relative velocity? So it's basically like this, and this is the sum, this plus this.
that's yeah.
Okay. So this is another way we can say, but for the relative velocity, we usually use the normal formula is VAB equals to VA minus VB.
Okay.
So it's kind of like if we are considering, let me draw another figure. So say for example, this is an object with, because we are using the VA and BV notation, we can
Yeah.
say, okay, this is the object A, VA,
Yeah.
and another object, this is like moving at this direction, VB.
Yeah.
Okay, now if we want to find out the relative velocity is this is the relative velocity. Let me give another color just to make you understand. Okay, so you can say that, okay, so we see that, you see, this is VAB.
Yeah.
I use the other color, so maybe I remove this. So whenever we say that, okay, it's VAB or VBA, how do you? So if it is VBA, B to A,
Yeah.
and VAB, A to B.
B.
You understand my point? So
Yeah.
it's VBA.
B. Yeah.
So from the vector thing, okay, you can say that, okay, VB plus VBA,
Yeah.
VB plus VBA
Yeah.
equals to VA. Am I right?
Yeah. Yeah.
I'm just thinking whether did I make a mistake.
VB squared plus VBA squared.
No, no, no,
Is it,
no. I used the wrong notation here. Okay. So VAB equals to VA minus V.
B,
That means whenever we are assuming the VAB, you see we are keeping the B as a constant kind of thing, and
yeah,
look, the arrow head is towards the motion of A. You see,
yes,
from this is AB, the relative velocity of A, the velocity of A with respect to B. That's why
okay,
the
yeah,
relative motion or relative velocity of
yeah,
A with respect to B. Clear?
yeah,
Or if we write it the other way, like if you just keep it VA equals to VB plus VA, isn't it something like that?
yeah,
Okay. So
yeah,
we look into this formula
okay,
here. So for relative motion analysis, you see like what is happening. Okay.
okay,
So we have a general plane motion.
yeah,
General plane motion is what is general plane motion? General plane motion, it undergoes like the translation and the rotation. Okay,
yeah.
because your teachers notice little bit. So it's the translations. What is translation?
Translation means it's just moving. Like it's not like you're just moving from one
One
end to
point
the
to
other
another.
to another point. Yeah,
Okay, so it's moving. So you see, at
yeah,
time t, it was here.
yeah,
At time t plus delta t,
yeah.
it moved
To another
and
point.
also rotated. You see,
Yeah. So it's general
like
plane motion.
yeah, general plane motion. So it's not
Yeah,
it's not this position. Okay,
yeah,
it has moved from here to here. This much is the displacement,
yeah.
and there is a rotation also. There is a rotation
Rotation.
also. So
Yeah,
that's why it's a general plane motions. That means it has a translation and it has a rotation.
rotation.
Okay, you see how much it
Yeah,
has translated and
yeah.
how much it has rotated.
Rotated.
Okay, so how did they do that? So for that,
Yeah,
they do a how to say, they did a, you see, a parallel line, draw a parallel line.
yeah,
Okay, then they fix one point and then they move the other point. Okay,
yeah,
now from the displacement perspective, if you look at here, okay, you see the displacement of DRA. Can you
yeah,
see it? This is the
yep.
DRA.
Okay.
So we keep the smaller one as a reference. So DRA, DRA. So DRB is basically DRA plus DBA, DRBA. You understand my point?
DRB.
This is pretty important that you understand this.
So
Can you see?
DRA. So from B to B prime, it's DRA.
Yeah. So they did a like draw the same thing here, here. Why? Because this makes, because if I draw it here,
It's
the A is
translation.
not here. A is
Oh,
here.
okay. Yeah,
That's why we draw a parallel thing that is here. This one, this one. So this mass displacement is dr. This mass displacement is dra. You see?
yeah, yeah,
From here to here. What is the displacement of a point? Okay. Now, since this one and this one parallel, then we can also say, okay, this is also dra. Am I
yep,
right? If this
yep.
is
You're right.
dra, this is also dra.
DRA.
Because this is
Yeah,
parallel. Okay, so if the vector is parallel, it has the same direction.
yeah,
Okay. And what is the point B? Point B is not here. point B, it has moved this much. Okay.
Yeah.
So we draw a line here. So DRB. Now, if we want to draw a relationship, now you see, sorry. So this is our DRA vector. Okay. This
Yeah.
is our DRB.
RB. Yeah.
Now, what is this vector? Okay. So this vector is basically, this is the displacement of which point? A point or B point?
Uh, B point.
B
So
point.
because
So
it's going to
DRB with respect to A. Clear?
Okay.
This is a point of the B point is not here. B point has moved here. That means
Okay.
it has undergone a rotation. That's why B is here. So the B has moved relative to A. You understand my point?
Okay. Yeah.
B has, so that's why DRBA, not AB.
Yeah.
DRBA.
B.
Now, from the vector notation, what you can say? This much plus
Yeah.
this much. If we
Yeah.
go like this much, then we go this much, we end up with this,
Okay.
isn't it? So what
Yeah.
you can write? DRA plus
DRA plus DRB.
A
A.
with
A.
respect to A equals to,
DRB.
clear? Do you understand why it's like
Okay.
if you start from point A, okay,
Yeah.
let me give another because A, B, C. If we start
Yeah.
from point B,
Yeah.
then if we reach B prime,
Yeah. Yeah.
okay, let me give it the B initial, it's the B final, okay, so that you understand. So from B initial to B prime, then if you go to BF, then what is DRA plus DRBA, isn't it? Something like that. We are
Yeah.
moving from where? We are moving from B initial to BF,
B final. Yeah.
and this is also B initial to B final.
BF.
Okay, clear?
Okay.
Now
That's
you now you understand the relative. This is called
okay.
relative.
Okay.
It's a displacement. This is just
A
displacement.
displacement.
Here, this is
Okay.
not speed. Sorry, velocity. This is not velocity. This is displacement.
Okay.
Okay. Now, pretty much like if you just divide it by the time,
Yeah.
then what it becomes? Rate of displacement is velocity.
Yep.
Like you see, for point B, it's a VB equals
Yeah.
to
Yeah.
VA plus VBA.
B. Yeah.
Just we wrote it here. Like if you write it another way, because it's the VBA, VBA.
BA.
So
So
the
what is
where,
the yeah?
huh?
What's the BA mean again? Sorry, that's the B
Okay,
slash A.
VBA,
Yes.
relative velocity of, maybe I write in one line, relative velocity of B. Maybe I give you relative velocity of V with respect to, you understand the short form? With respect
Yep.
to
Yep.
A. With respect to A.
A.
And the other notation is VAB, relative velocity of A.
Yeah.
Okay. Of A with
Yeah.
respect to B. Okay,
Yeah.
clear now?
Yep.
So VB is a relative velocity of B with respect to A. VAB means relative velocity of A with respect to B. Clear now? Hello?
Relative velocity A with respect to B.
Yeah, so VA, VB. You understand my point? VA,
Yeah.
VB, this is not a relative velocity. It's just velocity. Okay, absolute velocity.
Okay. Yeah.
And this is absolute velocity of A. And
Yeah.
this is the relative velocity of B with respect to A.
A.
Clear?
Yeah.
Now, here we have to understand one thing, that is, how do we do that? Like the VBA, what does it mean? So here we have if there is a rotation
Yeah.
for point B, like the point B, it undergone a rotation. Am I right?
Yeah.
How much rotation? It's d theta.
D theta
So
rotation.
if you remember, when an object it rotates, if the radius is r, what is the speed at this instant? V equals to omega r. You remember?
Yep.
V equals to omega times
Omega R. R.
r. What is r? R is the radius
Yeah.
of the center, radius of the center,
Yeah.
about from the radius of the circle about from this for this rotation path.
Yeah.
Am I right?
Yeah.
So
Yeah. Yes.
similarly, if we look at here, you see,
Yeah.
what is so we can also say, okay, this rotation, this relative motion has a rotation part. So
Yeah.
the linear velocity will be angular velocity times the radius.
Okay.
Angular velocity times the radius.
Radius. Yeah.
And what is that radius? You see, because it's rotating about, the B is rotating with respect to A.
A.
So it's a
Okay.
position vector from A to B.
B.
It's
Okay.
it's a position vector from A
A
to
to B.
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 Or
Yeah.
you can say that it's a position vector of B with
Okay.
respect to A.
A. Okay.
Okay? It's a
Yeah.
position vector of B
B.
with respect to A.
Okay.
Clear?
Yes.
So this is the main formula that we will use. So basically, if we rewrite it here, this is the formula. For velocity analysis, you have to use this formula. Clear?
Yeah. Okay. Good.
Let's jump into solving some problem.
Equations.
Okay.
Yes.
So for acceleration, you just take a derivative to find
Yeah.
the acceleration.
Okay.
Okay. So we'll cover the acceleration afterwards. Before that, we just finish the velocity first. Okay. Because for acceleration, we have to see the tangential part and the normal part.
Yeah.
Okay. Another motion is rolling motion.
Yeah.
Okay. So for rolling motion, you know where the instantaneous center is.
Yeah.
For rolling motion, the center is not the of zero or how to say. This is not the center. This is the center of instantaneous velocity. For velocity, I'm not
Yeah.
talking about acceleration. Okay.
Okay.
I'm just talking about velocity.
Velocity.
Okay. So let's see what they have done here. They don't have any problem with respect to velocity.
Yeah.
So do you have in-class problem or?
Yeah. I should have it as well.
Okay.
Like instantaneous.
You
Like
already shared with me?
no, those are the lectures. So are you talking about instantaneous center of zero velocity problem, or are you talking about the one with? I know we're on the
Velocity,
acceleration.
absolute velocity analysis.
Absolutely.
Did you give it to me before?
I did.
Okay, let me check. If you already did it, then why do we need again?
Like where we had to find angular velocity and
This is some more. I'm wondering whether they use this formula. It's pretty much important that we solve each and every notes that they have given to you. Okay, we'll solve it. This is in class. Okay, so for these problems, we have to. I'm just wondering about some given problems, like solve problems. Yes, I don't want to spend much time on thinking and then solving. Did you use this formula for any solving? Yeah?
which one is this? This is the no, I haven't done these now. This is for instantaneous center, right?
No, this is not intense instantaneous center. This is for that thing. I'm just wondering, okay, because they have like you also have a challenge here about the like two-dimensional thing. Okay, like if it's a two-dimensional problem,
Okay.
then you have the like the vector notation, like the
Yeah.
x direction, y directions, and whether you are doing with respect to the uh, how to say, with respect to the ij coordinate, or you are doing the absolute thing. Okay,
Okay.
so before we talk too much, let's solve this maths first. Okay,
Yeah.
we improve our knowledge, then we'll see, because today we have to uh, upgrade our knowledge a little bit. Okay, okay. So this is in class problem week 10.
Yes. Yeah. These are the instantaneous center problems.
In class, I don't think so. They are not doing anything instantaneous center. It doesn't
This is
seem like that.
instantaneous center. This is
Hmm?
instantaneous center
Let's see.
of zero velocity.
So do you have absolute for the week 10 or? Yeah, I can say it's instantaneous center. I see. You're right. Hello?
Yep. Yep. I'm here.
Yeah, they have done this with using the IC instantaneous
Okay.
center. Where is the other node in class?
Absolute. Hold up. Let me.
This one? I
Hold up.
think
I'm going
this
to
one.
sending it right now. Just give me one second.
Can you see my screen? I think it's this
Uh,
one. Week 9, is
yes.
it?
Yes.
In class
That's
problems, week 9 solutions.
yes. That's
Okay.
yes. It's this one. Yeah. Yeah.
Okay. Okay. Because let's see how did they do it. then we'll see. Because I don't know what your teacher followed the same way, or she used some IJK coordinate.
She didn't use IJK, no.
Okay, so that's what I
For
want to
video
double
science, no.
confirm, because
No,
if
she wasn't
she's
using IJK.
okay. So let's see the problem. At the instant shown, theta equals to 60 degree. So this is theta
Okay.
equals to 60 degree.
Yeah.
Okay, here is 60 degree.
Yep.
The rod AB is subjected to a deceleration of 16 meter per second square.
Yeah.
That means rod A, this one, is having a deceleration. So you see the notation, it's a linear or it's the angular deceleration.
Like for
So
which one? The
uh, is it alpha or is it A?
Oh, it's acceleration. Like oh
That's what I'm trying to say.
I'm pretty sure it's A for acceleration because it's meters per second
Yeah,
squared.
yeah, that's what. Okay.
Yeah.
So you have to. So this is basically
Yeah.
the okay. So it's A.
Yeah.
A means can you have the formula for the calculus formula? dv over
D
dt
dt. Yeah.
or d square x over dt square, something like that.
Yeah.
Okay.
Yes.
Okay. When the velocity is 10 meter per second.
Second. Yep.
So this is at this instant, at this
Okay.
moment.
Yeah.
Okay. So at this moment, we know the velocity of rod AB.
Yeah.
And so rod AB is this. So this is A. You
Yeah.
see here, they have shown us the horizontal velocity, and the
Yeah.
deceleration means like the speed is decreasing. Like at
Yeah.
some point, it will be like stopping.
Yeah.
Now determine the angular velocity and angular acceleration of link CD.
Yeah.
So we have to find out the angular velocity and angular acceleration of CD.
Link CD. Yeah.
Okay. So basically, since we are not using any relative velocity equation here
Yeah.
at this moment, so we will go one by one.
Okay.
We'll go one by one.
One.
So first of all, what we want to see, okay, if it is moving to the left, then what is happening to this gap with respect to this point? You see?
Yeah.
So we denote this as a x. We denote
Yeah.
this as a x.
X.
So from here, what you can say, like if this is a triangle, if this is a triangle, and we know the how to say, we know the length and we know the angle, but we are going to keep the angle as a variable. Why? Because if it moves, then the angle is going to change.
Yeah.
But the length are not gonna change. The
Change.
length,
No.
is it going to change? Like
No, it's not
300
gonna change.
millimeter, it's not gonna change.
Change. No.
So the theta is gonna change. So
Yeah.
the variable is x theta.
Yeah.
Now, if we look at here, since this is 60, this is 60, and
Yeah.
this is 200, 300, this is 300. So this
Yeah.
is a triangle with two sides same.
Yeah.
Triangles with two sides same,
Same.
and two angles same. So
Yeah.
we can easily find out the x. How do you find it out? X in terms of theta. So you can think about this is a right angle triangle. Am I right?
Yeah.
This is a right angle triangle.
Yeah.
So right angle triangle, this is x over 2. Am I right? This is x
Yeah.
by 2. Why?
Two.
Because since this angle as this angle equal, so if we draw a perpendicular, so it will bisect. It will bisect.
Yep.
Okay, so this much will be x over 2.
2.
You can give another name, okay, x1 and x2, then you determine x1 plus x2, but here is x over 2.
Yeah.
So since we know the hypotenuse, and this is adjacent, am I right?
Yeah.
So which formula we'll use? Cos theta, sin theta, or tan theta? Do you remember the formula for the sin theta equals to what? For a right angle triangle?
Sine. Sorry. Opposite over hypotenuse.
You see?
Yeah.
For if a right angle triangle, the hypotenuse is always opposite to the right angle. Hypotenuse is
Yes.
always opposite to the right angle. Like
Right angle. Yes.
if kind of this, so this is right angle, so this is hypo.
Yeah.
And if we take this as an angle, theta, then it becomes the adjacent.
Yeah.
Adjacent mean the angle with the other side other than the hypo.
Yeah.
That is the angle we are taking, that is adjacent, and this is oppo.
Yeah.
So it's not like the vertical or horizontal. You see the here opposite is horizontal, here opposite is vertical.
Vertical. Yeah.
So sine theta is basically opposite over hypotenuse. Clear?
Hypotenuse. Yeah.
Now in this triangle, this is my 90-degree angle,
Yeah.
isn't it? So
Yep.
if this is the angle, then it becomes adjacent, and this is hypo. Clear?
Yep.
So if we use the sign, then it oppo hypo. So does it work?
Yeah.
We need a relationship between adjacent and hypo.
Yeah. So it's cos.
So it's cos. So you see which formula you use, it's determined. So if you confused about the formula, then it will take a lot of time here. You lose a lot of time. Okay.
Yeah.
So here, if we take the cos theta, what is my adjacent? This value, am I right?
Yeah.
It
X
can
over
be
2.
let's forget about x by 2. Okay,
Yeah.
let me give you a generalized, because not always this angle is gonna be the same. Okay, so let's say this is x1 and this is x2.
Okay.
So we can say that x1 over 300.
Yeah.
So x1 equals to 300 cos theta.
Cos theta. Yep.
We can do one thing. You see, the speed are in meter per second and this length is millimeter. So we can say that this is 0.3 meter, because to be consistent, okay, in units. So let's do it in meter. So 0.3 meter, and this is 0.3 meter. Clear?
Yeah.
Now, similarly for this triangle, the other triangle, BC, okay, you can give another, like this is, I give a new point, C prime.
Yes.
Okay, so this is triangle a DCC prime. Similarly, BCC prime. So cos theta, because the theta is same. The theta is same.
Same. So
Cos
cos theta is equal to
x2 over
x2 over
0.3.
Okay.
Clear? So therefore, x2 equals to 0.3 cos theta. Clear?
Yep. Okay. That's clear.
So what is our x? Because we have to go to x. We have to go to x. So x equals to x1 plus x2. Am I right?
Yep.
So it's basically 0.6 cos theta.
Theta.
So now we have a relationship between the linear and angular.
Yep.
Clear?
Yep. That's good.
Now we have to, for linear, this is a displacement or position. This is position, angular rotation, angular displacement. So how do
Yes.
we find out the linear speed? What do we need to do? This is x.
Yes.
What is the relationship between the this x and the velocity? V equals to dx over calculus relationship. Do you know this formula?
Yes. Dx is equal to dt.
So in your brain, it has to be like ABCD, okay?
Yes.
When I ask you, you have to always, what is our acceleration
Acceleration is dv over dt.
and other in terms of
Is
x, d
uh
square,
oh d squared x over d squared t or
dt
dt
square,
squared. Yes.
and
Yes.
another one in terms of dx.
Uh, in terms of dx.
You'll also have to memorize those formulas. Okay, how do you do that? Like dv over dx times dx over dt. You understand my point?
dv over dx over times dx over dt. Okay.
So if you just take it out, then it becomes a dv over dt. Isn't it the same thing?
Yep.
Acceleration equal to dv over dt. So dv over dt. So we just multiply it with dx and divide it by dx. You understand my point?
Yep. Yeah, I understand your point.
So basically dx over dt is what? We know this formula dx over ddt of x is v.
Yeah.
ddt of x is v. So dv over dx, this is v.
Yep.
So v dv over dx. We also have the similar formula for the angular.
Yep.
Okay, omega equals to d theta over dt. Am I right?
Yep.
Omega equals to d theta over dt.
dt. Yeah.
And alpha is angular acceleration is
Angular acceleration is
d omega over
dt.
or d squared theta over dt square
dt
or
squared. Yes.
omega d omega over d theta.
dt. Yeah. Okay.
Not you see, you have the relation. X
Okay.
is the linear displacement and theta is the angular rotation. Clear?
Yeah.
So it has
That's
the
clear.
similar property. Like if you look at the formulas, so isn't it the same?
Yep.
Like the similar kind of thing. If you just, because this is pretty important that you understand. So this is linear, this is angular.
Okay.
You see, linear
Yep.
velocity, angular velocity, dx over dt and d theta over dt.
dt. Yeah.
And the acceleration is, because we wrote all these formulas, we just copy it here.
Yeah.
dv over dt d square x over dt square. And what else? We have another. That is what? V dv over dx. Clear?
Okay. Yes.
So similarly, angular thing, if you think about the angular, then
Yeah.
what is alpha?
Alpha is equal to dv over dt.
Yeah,
Sorry.
then
Equals
d omega over dt,
yeah.
not dv.
Okay. Hold on.
Because this is angular, so everything should be angular.
Okay.
You see?
Okay.
There is a nice relationship. You see, a dv over dt, d square x, dt square, v dv
Yes.
dx. Similarly,
Okay.
alpha d omega dt. You see, it's angular velocity, and this
Yeah.
is linear velocity. This is angular
Yeah.
acceleration, this is linear. Isn't it the same?
Yeah. It is
Exactly the same.
same.
And what is the condition for this formula? Like if we want to use this formula, like the other formulas, like if you remember omega equals to omega naught plus alpha t, you remember?
Okay. Yep. I remember.
V equals to v naught plus at So this formula, these are calculus. These are calculus formula. Am I right? These are calculus. And this formula, these linear formulas are applicable when the acceleration is constant. Remember, we had a math. Okay. So we did this kind of thing for, okay, let's not spend too much time on that. So we have relation x equal to 0.6 cos theta. Then what do you need to do for linear speed?